నా పాత వీడియో రికార్డ్ కాలే. Sorry. So I'll be explaining how to explore the data, and also this is a completion data notebook, and we'll be exploring the data using just simple pandas and numpy based on my last few videos where I was able to handle the missing values. And what else did I do? Did you watch my last videos? If you did not, then you can click on the playlist which is this side with the eye icon. And so I'm Samyukta, and I'll be telling you how to evaluate student summaries using simple numpy and pandas. And in this video I'll be handling missing values, handling categorical data which is not just numbers. It is has a lot of text and a lot of different types of data clubbed into a single cells, and which looks like text, but it is a string. So how to handle that kind of data, how to handle missing values and replace the values, and also how to use statistical libraries like numpy and pandas for creating new features. And it also comes under feature engineering, and also how to create target variables. So in this Kaggle competition, the goal and the target given by Kaggle in this competition is to evaluate the student summaries and predict what would be their content score and word score for the text which is written in the future. So simply they have given two kinds of CSV files, that is the essays train, the present essays, that is summaries train, and the summaries test set. And in this the train set we have a content score and the word score. And we in the prompt train we have four columns where prompts are basically kind of hints or any kind of essays which they have given to students for completing summarization and the assignments. So it's basically we can see them as practice questions. So in that we have the question ID of the prompt and the text and the title. And one thing which we have common between these two sets CSV files are the comma separated files is the prompt ID. So let's start this video. Okay, I'll be loading the prompts train set and seeing what kind of data is present in the train set. And we have four columns, and in this columns we have mostly string type of data and the identifier here. And let's see the information, the schema, how the data type look like. So everything is an object data type, something which is not integers or float or decimal data type is as defined as an object data type in Python. And we have 4 entries. That means it's a very small data set. Yeah, so we need a bigger data set because we want a lot of NaN values. And so I'll be telling you why do we actually need numpy when we have list, strings, and so many other data types. Why just numpy is given so much of importance in every course, in every video, in every data science scientist kind of roles? Why? So I'll be loading on the big data set, that is summary strain data set. And क्या है इसमें जांचते हैं हम. So we have student ID and the text or the summary which was given, and the content score, that is basically what is content score is the text, like how well the content is. This content score, you can read about that. Content score for summary, it's the first target. And the wording score is basically for each word a score is given. So this is the information we see the data has three object type and two integer floating values. So this looks like a big one, but it is not big data since we have just 7,000 entries. And I'll be loading the student ID, this particular complete column, using numpy arrays. And you see that the data is loaded into the numpy array. And mm, I wanted to explain the difference between the list, and I've stored it into a variable constant, and it is ID. And there is also another variable constant sid, where we store the student IDs. And to demonstrate the differences between the list and the numpy array, I have tried to multiply the array by 2 and the list also by 2. And by 2 I mean start 2. So, and also we see what would be the type of the list and the array. So we see that the list prints a list and as a type, and the numpy nd array prints a n-dimensional array. So n-dimensional array is, we can load multiple dimensions of data depending on the data frame size. And this also maybe has a limitation, and since it cannot store blob data or JSON data directly like the Hadoop HDFS file system. And when we multiply by 2, we see that each if this is till here the list, then after multiplying by 2 we see all these elements are repeated twice. And in SID start 2 we see that each element is treated like a vector or basically a string. So when you multiply strings, then they get added one after the other. So the same thing is repeated again over here also. So star 2 is it gets multiplied itself. And I wanted to see what would be the shape of the array, that is a size of the number of elements. So it is 7,000 plus entries. So to access the first element of this one, then I can do like s_underscore id of 0. You can iterate also using iter rows or iter columns in the ND array. And if you want to see, I wanted to use like a numpy for analytics. And we can see like using st.content.mean. Content had floating numbers like this, and wording also has floating numbers. So we can find mean, median, mode, or replace by mean, median, mode, or any kind of constant values or null values in this particular column, these both columns, numerical columns. And so I'm concatenating both these arrays. We can concatenate, we can find the mean, we can find the median, we can find the mode. And to see the scores shape size of this particular array, then it's a 2D array with 7,000 entries. And to actually access hierarchical positions, because there are double or triple, like how many ever brackets are there, like that 0 0, you can access using for loops and lambda functions. Or also you can just iterate using apply function as well. And you can find the average score of this particular array by average wording and average score. And we see that the content score is actually negative 0.01 and wording score is 0.06. This is quite interesting over here. Can you see the difference? For the first target we have 0.01, and for the second target we have 0.06. So content is the first target and wording is the second target. So average content score ఇక్కడ ఉంది, ఇప్పుడే కదా చూసిన. Average content score first target has and average wording score has lesser than content score for the second target. And finding and filtering data. So I've explained about LOCA and ilog for accessing data. So similarly in the numpy arrays also, and in data frames also, you can access using a .loc by giving the specific index, the fifth row. For the fifth row, you can see all this value, and to iterate and also to get the pros between two index values, then you can use 0 to 5. So in 0 to 5 means you get 5 rows, and all the data is displayed very well in ilog. And you can also like if I want to access just this particular one, like the text, then or this particular one, then I can write like std ilog of student id, and this is a 0th index, and in the first column, first row, second column, yeah, this is the 0 and this is the 1. So you get 1 comma 2, like this, 1 comma 2. So this is for the rows and this is for the columns. So first row 0 and column 1 and column 2. So all the first rows like this, it will get option. But this sounds very confusing for me, because you have to actually specify the numbers every time. So better than that is get and put functions, which are usually used in JSON and string personification. And while usually in fintech companies, they give queries, lot of queries for searching data in Jira portals, and also in their data visualization boards. So that data is completely striped out, and the logs are taken, and we use JSON personification, and use dot get or dot put, or dot get any string, dot contains or dot in, that kind of methods. And so std loc of 0 of student id, it will give you this first one. So you can remember like this is row and this is a column. So this is a 0th row and column is student id. So I'll be getting this one. So you can also use something like locating data. LOC is basically used for locating data. So in the prompt ID, we want to see what are the columns which I have prompt ID EB8026. So all the content, content wherever EB8026, if we wanted to display, then it will simply display it like this. And we can also reset the index if we want to store it as a different data frame, like by writing index is equal to some 1 2 3 4, or simply by reset underscore index is equal to true while creating new data frame. And we can also access the EABD26 like this, prompt id is equal 21. And so this is very easy to remember this particular grouping type, like last time I showed in the videos how to access the data. So uh, in this one you can also see the query prompt id EB8026 like this. You can query like this, but inside you have to give double quotes, and you can give access like this as well by giving the data frame value. And I'll be showing you how to handle missing values in the next video. Thank you.